Let's start with mathematics algebra. These are the topics that we will cover today. So let's start with logarithms. So logarithms is a way of expressing exponents. So when we look here at the base to the power of c equals x is the same as saying that c is the logarithm of x to the base b. So the logarithm of x, that's how we pronounce this one, to the base b equals c. Now we have two famous forms of logarithms. We have log. This log is basically log x to the base of 10. And then we have this other form here, which is len. Len is log x to the base of e. And this is the value of a, 2.71. And it's given the symbol, it's an irrational number given the symbol e. Now let's take an example here. What is the value of log 1000 to the base b? So we can write it as an exponent. So we have the base to the power of c, which will equal the x, which is 1000. So what is raised when we raise 10 to its power? It gives us 1000. So we could rewrite this as 10c. And 1000 is actually 10 to the power of 3. So now c equals 3. And the answer is B. So let me show you on the calculator where you can find this logarithm. So basically this here is the logarithm, as you can see, log. So the base, you can put it 10 to the power of 1000, or the x is 1000, it will give us 3. Now the other notation that you have mentioned, the log is here and the len is here, so they are all at this side of the calculator. Now let's look at some of the properties of the logarithm. The first one here is let's use the pen, this property here, which is log b to the base b to the power of n, is actually raised to the power. So basically we can cancel this one with this one and we are left with this one, so it's n. Same here, when we have a power to the x, we can take it outside as we did here. And here we have the anti-log. The anti-log is basically 10 to the power. So whatever inside the anti-log is 10 to the power. So this in this case, x to the power of c is simply 10 to the power of log 10 x to the power of c. So we can do this trick when we put log and then we, like we did here, when we cancel the log b with the b, we can cancel the 10 with the log here, and we are left with x to the power of c. So all I did here is reversing this one. Another property that we have here is when we have a the log of the multiplication is the addition of the log. So when we have multiplication inside, it turns into addition. Same with the division. So the log of the division is the subtraction of the logs. And then we have here, so simply this is one case of the property that we mentioned above. So you can cancel the log b with the b and you are left with 1, which is this one. And here it's simply when you have log, so there is a 10 here, but it's not written. And this one is actually 10 to the power of 0. So also as well, we can cancel the 10 with the 10 and we are left with 0. So these properties are all in the formula sheet. Let me show you. So we can go to page 34, I think. Yes, it's here. So we can find here the properties of the logs, the base, the log bx equals c. We can scroll down, we can see some of the identities of the logarithms. Okay, let's move on to this example. Which of the following is equal to this value? So basically one of the things that we mentioned that we could do is that we can put 10 to the power of log 10. We don't need to put the 10, and then we can put the value here. So that's what we will do here. So 10 to the power of something is nothing but anti-log. Okay, and we can put what's inside as 0.0 you can put what's inside in a log. So basically anti-log with the log cancels each other. So we will have here 0.001 to the power of 2 over 3. So adding the log with the anti-log does not change anything. So now what we can do is that we can take this 2 over 3 outside. So what we will end up with is anti-log of 2 over 3 log 0.001. So we can see that this answer is D. And be careful from answer A, because answer A is just flipped. The fractions just flipped, but the other values are the same. We can look in the calculator here that the anti-log does not exist. However, we can see that when you press shift with log, you will get this one, and then you can get log, and whatever value you will put here, you will get it as the result. So, because the anti-log, which is 10 to the power, and the log cancels each other. Same with the len, the anti-len. I'm not sure if that's a concept or not, but the anti-len is e to the power of something, and whatever we will put here, we will get it as, okay, sorry, I need to close the bracket. Whatever we put here, we will get as the answer. Now, another property is change in the base. So, for example, when we have a base b, and we want to change that base, so we want to convert from len, for example, to log. How can we do that? So one of the methods is that we can divide the fraction or split the fraction into the log into a fraction. So this base will be in the denominator, this will be in the denominator, and the base will be in the denominator. And this a here can be taken as any value. You could put 1, 2, 3, 10, e, pi, whatever value. You can use whatever value you want. So what we have here is, this is basically is log x to the base e. So what we did here is that we put the a from the formula above as 10, and then we evaluate the value of this term here. So it's 1 over log e to the base 10, and when you put that into the calculator, this is the number that you will get. And this is how we convert from log to len. Of course, if you want the opposite, you can just divide by this one, and you will be able to convert from log to 10. So this is a formula to convert between common and natural logarithm quickly. All right, and this formula actually exists in the formula sheet. We can see it right here. Yes, here it is. Okay, now let's take a question here, and this question wants us to use the formula that we have found earlier. Of course, you can just plug it into the calculator, but let us do it in the way the book wants us to do it. So it's log, we have 9 above, so we can put 10 at the denominator, and we have 9 here, and this is divided by log 10, log 9 to the base 10. So what does these values equal? We can get it from the question itself. So log 9 to the base 10 is 0.9542, and log here it's actually 5 to the base 10. So 5 to the base 10 is 0.6990, and let us use the calculator for that. So the answer is 1.365. All right, so the answer is D.